Okay, now that we've discussed the basics of Lean, let's talk about the basics of Six Sigma, the second half of that. Okay, so our lesson topics are going to be the meaning of Six Sigma, the history behind it, as well as the cost of poor quality, probably the most important Six Sigma metric, and some other Six Sigma metrics. Okay, so the meaning of Six Sigma. What does Six Sigma really mean? Now, in statistics, sigma is our standard deviation. It's how close our data is to the average. Our data could be spread out, or it could be really close together. Our sigma, or our standard deviation, is going to help us to understand that. And our sigma level is how many standard deviations fit between the average and a customer limit. And if we have 6 standard deviations that fit between that average and a customer limit, we've achieved Six Sigma. Okay, that's our sigma level. How many standard deviations fit between the average and a customer limit? So let's take an example here of a process for shipping orders. So let's say that on average, it takes 3 days to get an order to a customer. That's the average. And a customer limit is 9 days. So basically, customers have told us if shipments take longer than that, they're going to be frustrated. They're going to end up going to another company. It's going to be bad news for us, bad news for them. Okay. So the question becomes, now that we have this window, 3 days, which is our average, and 9 days, which is the customer limit, we've got 6 days to work with. 6 days in between those. Now, if our standard deviation is 6, there's only 1 sigma that fits in that window. So we'd be at 1 sigma. But if our standard deviation was 2, there'd be 3 sigma that would fit in that window. 2 times 3 is our 6 days. That's 6-day window. So how many standard deviations fit within that 6-day period? That's what we're taking a look at to figure out what our sigma level is. Okay, let's take another process. Let's say we're handling customer support calls. And one key metric that we look at is the percentage of calls that go unanswered. When our customers call, we want to make sure that there's someone there to pick it up and hopefully resolve their issue on the first attempt. Okay, so let's say the average of the process is 9.5%. 9.5% of calls go unanswered. And the standard deviation is 1.5%. And then our upper specification limit is 15%. And our sigma level will be 3 in that case. So if our average is 9.5 and our upper specification limit is 15, if we look at that window and how many standard deviations fit between it, it'd be 3. 3 and a little bit more. So 3 would be our sigma level. We've got 9.5 as our average, 15 is our limit. So we got about 6.5% to work with. So at least 3 standard deviations fit in that area. Okay. So Six Sigma also represents that there are 3.4 defects per million opportunities. So we've gotten our process to a point where we have very few problems. 3.4 defects per million opportunities or fewer. It essentially means 99.9997% defect free. And you might be thinking, gosh, that's really almost impossible, right? It's challenging, and in most cases, we never get there. It just shows us that there's always room for improvement. We can always be cutting down on defects and issues in the production process. Here's another way to look at it. If you look at each of the sigma levels, 1 to 6, it shows you roughly how many defects per million opportunities we're looking at.